Alright, so problem 3 is where we combine the force of gravity with the concepts of uniform circular motion. So here we go. Two stars, A and B, are in circular orbits of radii RA and RB respectively, about their common center of mass at point P as shown above. Each star has the same period of revolution t so that they always appear as shown in the image below. Determine expressions for the following three quantities in terms of RA, RB, the period t, and fundamental constants. I want to point out to you how crucial this little phrase is. One is determine expressions. So I don't have numbers for you. You have to realize that you need to manipulate equations. But I want it in terms of RA, RB, T, which is the period, and fundamental constants. That's it. If you used anything than RA, RB, T, and fundamental constants, you didn't get a whole lot of points for this. Because I want you to see how everything is dependent on those really 3 and maybe 4 things. And I mean everything, down to part C. So, here we go, let's dive in. The speed of a star. A lot of people try to do something fancy with this. F equals ma, put in mv squared, solve for v. But realize m is involved in that. Acceleration, all sorts of stuff that you couldn't know. The forces. I needed the speed of VA and VB. So there was an equation on the board that said velocity is distance over time. And since we were going in a circle, we would see that it was 2 pi times their radii over the period. So for VA, we just replace it. 2 pi RA over the period, T. So realize A has this radii, and it makes this loop. B has this radii, and it makes this loop. And so they're covering this, they're making these circles at the same rate. So one of them must be going faster. You could have compared that, and that would have been a good question to ask, is which star is going faster? The answer would be B, but all I wanted you to do was find the equation. So VB, so let's check, make sure this works. 2 pi, that is a fundamental constant. RA and RB are both terms that we can use, and T, the period, is another term we can use, so that's it. Now, I want you to find the centripetal acceleration of star A, AA, acceleration of A, and B, acceleration of B. So, you need to think, what is the equation for centripetal acceleration? This is one that's given on the AP test. It's V squared over R. So R, that's good. We have R, but notice we don't have V. Oh wait, we do from above. So if you messed up on part A, I gave you credit if you used it in part B, but only if you still follow this in the terms of rule, right? So A of A would equal VA squared over RA. So we had to plug everything in. So I'm going to square everything in VA, and then I'm going to multiply it by 1 over RA. So we've got 4, we've got pi squared, we've got RA squared over the period squared. And notice one of these RAs would cancel out this RA. So we're left with 4 pi squared RA over the period squared. And since VA and VB were very similar, you could then logically conclude that AB would have to be, and those two are our answers for our centripetal acceleration for star A and star B. Notice how it's 4 pi, a number, and pi, another number, so those are fundamental constants in terms of R and in terms of the period, which is legal for this. Okay, so remember that this in the terms of things still applies. So now we're going to do part C. So I moved the answers down here for parts A and B just in case we need them, since all of these things are in terms of RA, T, RB and the fundamental constants. So here we go. The mass mb of star B is something we want to determine. And I give you this hint. Ask yourself, what force is causing the centripetal motion? Nearly everyone thought this. And the distance of separation is between both planets. So I'm asking for mass. I give you a hint for what force. So you could start with sum of all forces equals ma and see where we go. But you have to think of what planet do you want to look at to find the mass of that planet. And this was why I made part C bonus, because it's a little tricky. You might think, okay, I want to find MB, so I'm going to look at MB. In actuality, I want you to realize that there's a force of gravity that is actually causing my acceleration. Then, force of gravity is going to be G, which is a constant, MA, MB, over the distance of separation between those two planets. So from A and B, a lot of people did a great job of reading this hint that the distance is going to be RA plus RB. I gave some bonus points just for identifying that. And remember that all of that had to be squared. So I need to think, what mass should I actually look at? Well, I'm looking for mass of B, and I don't know mass of A. You cannot have your answer in terms of mass of A. So to keep this mass of B here, this must be the mass of planet A. So we're actually looking at what's happening to planet A, and from that, we're figuring out the mass of planet B. Kind of interesting. Also note, I am going in a circle, so this is centripetal acceleration. So we have the velocity of A squared over R, or you can realize all of that is just, RA, or all of that is AC, A. And so we can replace that with this down here. So this is where this gets fun. Everybody brought mass, so MA is going to cancel. And so I'm going to rewrite it in here. I'm going to change color just so I can make sure we all see it. And I want to get mass of B by itself, so let's do that. RA plus B, RB squared is going to go on top. So we're going to have 4 pi squared RA times the quantity RA plus RB quantity squared divided by the period squared. But realize I also have to divide G over. Here we go. Let's double check. 4 pi squared, that's a fundamental constant. RA, that's something we could use. RA, RB, both things we can use. G, universal gravitational constant. It's fundamental constant, we can use that. T is my period, and it's squared, so just period multiple times. So all of this will allow me to get the mass of B. Thanks for watching the test corrections and doing so in a timely manner. Please turn them in as soon as you can. I will get them in the gradebook. The sooner you can, the better. That way, grades and stuff aren't kind of crazy right before finals come around. Please come after school as soon as you need help with anything, especially this. Make sure you have this. Some of this stuff will be on your final.